Subscribe and press this bell icon to never miss another lecture video. Hi, welcome back. We are in lecture number 66 of Signals and System, and we are still in the module of Fourier transform. And here in this video lecture, we are going to discuss about Fourier transform of complex exponential. So there are various important properties, important conceptual questions that we are going to discuss here in lecture number 66. Now, for example, the complex Fourier transform of complex exponential that we are going to discuss here. Also, we're going to discuss here the Fourier transform of a periodic signals. Okay, we know Fourier transform is actually method of representation or method of representing a time domain signal in frequency domain. If the signal is periodic or non-periodic doesn't matter. If it is periodic, the Fourier representation specifically, that is Fourier series. But if it is periodic or non-periodic, any kind of function it could be, that representation will be Fourier transform. Fourier transform is the method in which you can represent any kind of signals, periodic or non-periodic. So till now, mostly Fourier transform is mostly useful for non-periodic signals, but here how it will going to respond for a periodic signal, that we are going to discuss here. So there is a very important point with this which is associated with this periodic signal, and also we'll go and revisit a couple of properties like time shifting properties and the important concept that is associated with this time shifting property. Also a couple of very important conceptual questions, frequency shifting properties and concepts which is associated with this frequency shifting properties, and also 2-3 very important conceptual examples that we are going to discuss here in lecture video. So after the finishing of this lecture video, you're not going to have any kind of doubt on complex exponential thing. After this video lecture, we'll get into the video lecture of Fourier transform of various pulses. That video lecture are also going to be very important. This is extremely important, my dear friends, so be careful with this thing because a lot of people get confused with this concept. Okay, so till now, let's start with this lecture video. Till now, what are the things that we have studied so far? Real exponential, the Fourier transform of real exponential, Fourier transform of couple of standard signals, and now here we are getting into complex exponential, Fourier transform of a complex exponential. Now, what is a complex exponential? What is a real exponential? E to the power at. What is this? So this one is a real exponential, e to the power j omega t. What is this? Or j at, anything the way that you can write. So what is this? So this is a complex exponential cell. Yes, absolutely correct. You can write down omega t. What is this? A real exponential cell, or at ke badle you can write it down e to the power j omega t. What is this? So this is a complex exponential, sir. Absolutely correct. So till now we have seen how to do, like how we should approach for the real exponential. Now from now onwards, we're going to see various concepts which are associated with finding out the Fourier transform of complex exponential. Okay, it's a very simple thing. Look here carefully. It is saying what is the Fourier transform? What is the Fourier transform of e to the power j omega naught t? Now we know, if you go through the method of doing it, so there is two way of doing it. We know this. You can do this in this way: e to the power j omega naught t into e to the power minus j omega t dt, and take the integration from minus infinity to infinity. This is the method through which the standard method of finding out the Fourier transform of this function. We know this. Formula wise we can go and find it out. Okay, now this doesn't matter actually. You can find it out in this way, but let's always go through the properties. So we know there is this property which is called frequency shifting property. So what is the frequency shifting property? Frequency shifting property is, if there is any function like f of t, if there is any function, okay, let me take x of t. If there is a function x of t, when it is multiplied with e to the power j omega naught t, then in Fourier transform of these two, Fourier transform with these two in frequency domain, the frequency is shifted by. So we know this concept, we have a clarity on this concept. Now here, what is the x of t here? X of t here is 1. Okay, now we know the Fourier transform of x of t is x of omega. That is why we know the Fourier transform of x of t is nothing but x of omega. That is why we choose, when this is multiplied with any complex exponential, it got shifted by omega minus omega naught. But here, as we have a 1 here, what is the Fourier transform of 1? What is the Fourier transform of 1? Sir, Fourier transform of 1 is 2 pi del of omega. Absolutely correct. So what will be the Fourier transform of 1 into when it is multiplied with any complex exponential? So the answer will be 2 pi del of omega minus omega naught. Absolutely correct. So this is how you need to find out the value of, that is, Fourier transform of any complex exponential. Similarly, if instead of this plus value, if it is minus j omega naught t, you'll get 2 pi del omega plus omega naught. That means conceptually you can see, if there is any complex exponential is here, the Fourier transform of any complex exponential will give you a pulse, a simple pulse in a frequency domain. So if it is e to the power j omega naught t, it will going to give you plus omega. At plus omega naught you'll get a pulse, and if it is minus j omega naught t, you'll get a pulse at minus omega naught. It's a very basic concept. Please do write it down in your own language. Okay, now we are going into a little bit conceptual after this. Look here carefully. What we are going to do, we know the Fourier transform of this complex exponential term, and we know the Fourier transform of this complex exponential term. Now we are going to add both of them. If you add both of them, look here carefully. I added both of them. Just forget about divided by 2. If you add both of them, you will get this kind of expression. Obviously, if you add these two equations, you're going to get this kind of equation. Now let's do divide by 2. So there will be divisible by 2 value will be there. Yes or no? Now we know this is nothing but, instead of writing down this much, you can write down this is nothing but the expression for, okay, this is the expression for whom? ये किसका expression है? Sir, cos omega naught t. This is the expression for cos omega naught t, sir. हाँ. So instead of writing down this, I can write down Fourier transform of cos omega naught t. Yes or no? Now what will be the Fourier transform of cos omega naught t? Now you can understand 2 pi by 2 del of omega minus omega naught plus del of omega plus omega naught. That means these two values, these two graphs will be added with each other. Clear with this concept? But if you take for sine omega naught t, wahan you have divided by 2, and here you just need divided by 2j, and you need to subtract these two equations. There is nothing rocket science there. Okay, so there you're going to get del of omega minus omega naught minus del of omega plus omega naught. That means you need to subtract these two graphs. Now what will be your final graph that you're going to get? Look here carefully. It's a very simple concept. Now let's move to the next concept. It's a very simple, and all of you, I think most of you know this concept. I'm just exaggerating all of this. So this is nothing but cos omega naught t. Sine omega naught t. Clear? Now Moving into the very important concept, that is a Fourier transform of a periodic signal. For example, if x of t is a periodic signal, now we know if x of t is a periodic signal,